So Bobby and I are here to talk about the data side of RAG because, in my opinion, that's the most important. Um, but Bobby and I both come from the data side. He's much more trained than I am on all things data. But we'll just kind of jump into this. I just wanted to set the stage with kind of the steps of RAG for everybody that isn't aware. But so the first thing you've got to do is identify the documents, and then we
Yeah, I was gonna say, what's RAG?
probably a good call. So John Kalfayan, I do all things data at Collide. My background, I started as a frac engineer out in the field and then moved into the office doing technical support. Over time, I ended up working for a surface and downhole gauge company where we were doing a ton of high frequency time series data, and Excel wasn't cutting it, and so I had to learn how to deal with data that way, and that's kind of how I got into it. And at that same time, I started working with Bobby at that same company, and so anyway, um, I've been here at DW or Collide for over 3 years now, and so um, super excited for all y'all to be here today. I'll let you introduce yourself.
Yeah, and I'm Bobby Neelon. Currently at my own independent consulting for data analytics called Drill Down Analytics, hence the name of the segment. But been in the industry 11 years now. Started out at ConocoPhillips as a reservoir tech, and have along the way learned some software, data, cloud, all the things. Wore a lot of hats. RDS with John, and then worked at University Lands, and most recently at Grayson Mill Energy, where I basically built out the data team there and the data infrastructure, and sold to Devon and did my time at Devon, and now trying to bring the good news of data to a lot of companies across oil and gas. And I don't think we mentioned it too, but John and I co-host Energy Bites together as well. So
Interesting. Okay, so RAG stands for Retrieval Augmented Generation. I've got a slide after this that actually shows what that means, but the main steps for RAG data ingestion kind of boil down to these 6 things right here. So you've got to identify the documents, the type of documents, then we classify them. So based off of, the type of document, how are we going to classify it? Is it a drilling report? Is it a post-job report? Is it a contract? Those sort of things. Then we have to go through and extract all the information from those documents. Next, we go through and we chunk that data, which we've got slides and I'll talk about. Then that data goes and gets embedded into a vector database, and then we can start searching on top of all of that. I also want this to be collaborative, so if you guys have questions any point along the way, please feel free to ask. But this is just a very basic representation of both the pipeline up here and then the actual RAG down here. But at the top, you can see we take a bunch of our documents and we chunk them and we embed them and put them in a vector database. And then down here, when you submit your query, the query itself goes into the vector embedding, finds the top K matches from the vector database, and then passes those down into the language model to generate your response. I think that's one of the biggest misconceptions with, it is the biggest difference between a RAG and a traditional model, but this is one of the biggest misconceptions as well. It's like a language model and a RAG isn't involved into the very last step, essentially. So a language model is not touching the data. It's being fed data from your initial search, and that's what it's constrained to, essentially.
John, can you simplify chunking and vector?
Yes, in about 6 slides. So I rolled all of these things into one just to give you, I've got a bunch of screenshots and real world examples in here, but all data are not created equally. So obviously we have our traditional things that we think of for RAG, like PDFs and documents and PowerPoints and things like that. But of course, our industry loves to work out of Excel files and CSVs. Also, another big piece is audio and video. People don't think about that as data that you can search across generally, but the text or the speech to text technology has gotten incredibly it's better, faster, and cheaper. And so now we can actually use video content or audio content and transcribe that. And now we have text data that we can also add to these data sets. But it's not just identifying the file types. It's for each of these files, as you can kind of tell, we've got to go through and we've got to identify the layout. We've got to identify if there's any images. We've got to extract the text. Also, if it's an academic paper or a textbook or something like that, it's going to have LaTeX in it, which is another fun. That's those are basically formulas. That is a different thing that you've got to extract. We've got tables that are also from CSVs and from PowerPoints and docx's, which are really, really, really fun. And then, of course, transcripts. And then taking that a step further, we've got to go and generate a bunch of metadata around that. We generate captions and descriptions of the images from the documents and from the diagrams, and then we recognize all the text and stuff. So this is before we've done any chunking, any embedding. This is the hard part of RAG, in all honesty, or one of the big hard parts. It takes a ton of work. And so to give you some examples, over here we've got this wiki article, right? So there's a bunch of LaTeX mixed in with words in a fairly structured, format. Over here we've got an academic paper, from Arvix or wherever this is from, which, okay, cool, it's a text document, but we've got columns in this document, and then the next page of this document has columns in it, and so you have to understand the layout and be aware of what the layout is so that you can parse and extract the data correctly and with the right context. Another fun one, drilling. Here's a drilling survey up here that's in a PowerPoint or in a PDF document, but just a giant table that continues on for pages. And then probably the easiest and simplest form is like a contract where it's just a text file. But even the contracts that we've got have tables and different things in them as well. And so it gets very complicated very quickly. Everyone thinks, oh, it's in a PDF. A PDF is a PDF. PDF is just a dumpster fire for unstructured data. In all honesty, there's no structure to it. There's no format. There's nothing repeatable or anything like that. This, for example, these are the first 3 pages of a report that Buck has that are in his data set. We've got this crazy well schematic that everyone outside the industry has no idea what the hell that is. You've got a giant plot, and then you've got a bunch of tables. And so this is just the first 3 pages of this document that's probably dozens of pages long, but I say all of this to show you how complicated this really gets once you get into the data side of things.
I mean, John, just hold up there too, but you can go back. But I mean, we're in an age now where we're trying to get this out, put it into LLMs. How was this even being managed before? I mean,
That's a very valid point, right? Like Bobby and I were having this conversation earlier, and it's like nothing on the data side has changed now that AI has come along, other than the fact that it just highly exacerbates the problem that we have with bad data, bad structure, bad organization, and that sort of thing. Is that what you were asking?
I mean, yeah, but I think either before there was, parsing PDFs with Python, or previous OCR like Tesseract were things that people were using with some success, but very rarely. But even a lot of it, going back to the manpower thing, was just a tech taking these and hand entering these into WellView or stuff like that. Whereas like now, if we're able to reliably get this out with the newer OCR AI technologies and make it searchable, you're cutting out a lot of steps there.
Yeah, there's no reason anymore in our industry for us to be manually entering data from a report directly into a database, into WellView, into wherever that data needs to live. Humans hate doing that. We get tired. We don't, that's the last thing that someone wants to do. So the opportunities for fat fingering or screwing that up go up exponentially the more time they're doing that. But ultimately, if it's a repetitive, repeatable thing, then this is how we should do this. We should let AI pull it out of the document once it's processed and map it to where it needs to go. So the future from that perspective is very exciting. I think we're going to, like Colin mentioned, eliminate a lot of work that people just don't like. Everyone's worried about AI taking their jobs. Before that ever happens, it's going to make their jobs much nicer, much easier, much more fun, because it's going to eliminate a lot of the BS that they have to do on a day-to-day basis. But to Bobby's point, like historically speaking, you'd have to set up like all these OCR templates. And if everyone's ever worked with OCR, it can be very frustrating because if the formatting changes at all, it throws it all off, right? Now we've got OCR paired with vision models. So you're using computer vision and OCR, and the extraction process and stuff now is much more robust. Bobby and I have been working on some stuff, and he was like, I think I can just get Gemini to feed me the data right out of it. And I was like, you probably can, because Gemini's really good at classification and things like that. But then he ran into the same issues I ran into, that their API doesn't match what their front end does. And so the results are questionable. But that being said, the OCR, the being able to extract data from previously unextractable documents is very exciting, and the technology around that in the last 2-3 years has exploded. Another wonderful data format, revenue statement, clearly built by someone who has never dealt with data in their entire life at any kind of scale, because or intentionally, so that they could upsell someone on the CSV service that they also provide with this. But yeah. What's cool post-drop report? That one's actually really easy, right? Very straightforward, very fun. It's from Universal. Oh, wait a minute. There's another totally different format that Universal also uses in this beautifully bastardized, pivoted, messed up table that continues on for pages and pages and pages. This is like the real world that we're dealing with from a RAG perspective. And so this is where things get really tricky. I'm just trying to get all of that structured. This is the output from the extraction for that last document. And I pull this up just to show you how many different pieces of data we're pulling from this. I can't even read those numbers, but hundreds to thousands of different segments from just one post-job report.
One thing I will suggest is if you work with companies that provide data in this format, they actually have it in a database. And if you can get ahead of it, I mean, I think the problem now is like we're trying to play catch up, right? But if point forward basis, lean on your vendors to provide at the very least CSV copies of it, but access to a database, access to an API to get that data into a more structured format, because it exists somewhere. There's not someone, I hope there's not someone hand keying that information into these PDFs. But
well, I mean, you remember when we met with what's his name at Swin back in the RDS days, and he was tasked with building a machine learning model for predictive frac stuff, screen outs, etc. And he spent the first 9 months building a machine learning model that just went in and normalized the headers from the past 10 years of their frac data, because just the header data is not normalized. There's no structure. There's no consistency across it. And so, yes, anytime you can get structured, organized data, get it. Oh, handwriting. This is my favorite one. So this is a really cool example. These are some old files that we've got from a client. They scanned in all these banker boxes worth of data. Generally speaking now, the rule kind of that I've seen is if you can read the PDF, even if it's handwriting, there's a very good chance that we can extract the data from it. That being said, here's another wonderful example. I have no idea what any of this stuff says. Very hard to read. But my favorite part of it is that it extracted this butter and pain piece over here that is, I don't even know what they're trying to say right there, but it doesn't say butter and pain. So this is just an example that, as with all things data, if you feed it junk, you're going to get junk on the back end. So you can't just dump all of your data into a RAG model and magically hope, and it's just going to magically work.
Yeah, I mean, I think that's where we're going to, I know you're going to get more into some stuff around file structures and all that kind of stuff. But I mean, I guess to this, for the people here, I mean, is this something that Collide itself can extract, or you're using other models to extract and get the data into?
Yeah, we're using other tools to extract it to get it into the database.
So what are some of the ones that have worked well for you guys to get?
It genuinely depends. That's also the tricky part, right? Like for these post-job reports, for example, while I was working on this, Mistral came out with their OCR model, and I was super excited about it. Mistral makes really good products. And I got a couple files in, everything was looking great, and then I went and dumped it into just a CSV to look at it all, and it would just skip a page. For no reason, it would pull in the headers and then none of the data, 5 pages in. And I still have no explanation as to why it did that, but that's what happens with a lot of these. Actually, with these specifically, some of the best tooling that I found were just the traditional table from PDF libraries that have existed for years that aren't vision enabled or anything like that. So that's another piece of this. Just because it's new and shiny doesn't mean it's better than what has been around.
Yeah, I will say too, I mean, just I'm sure Bill will like this, but I think document intelligence and everything on Azure is very good. I mean, I've used it, especially when you have a structure, like if it's a consistent structure to it. I mean, it works really well. And I mean, at that point, you can start using it within like basically a data pipeline to get data from unstructured to structured.
Yeah, and there's a bunch of like new services out there that do this that they're Y Combinator backed or whatever, but most of them honestly appear to be wrappers around doc intelligence or something else. And so yes, we use a lot of doc intelligence internally as well. But again, I just want to point this out that like not all of our data is good. There is nasty stuff in there, and so we have to be cognizant of what we put into these things if we expect the outputs to be perfect. Chunking, fun. So there's a million different ways to chunk. Again, chunking is the concept of taking, let's say, a one page from a document and breaking it up into contextually relevant chunks. So you can chunk by page, so that would be like a fixed size chunking. You can chunk semantically, you can chunk recursively, you can chunk based off the document structure itself. So like typically most everything gets extracted into Markdown or HTML. And so because it's in Markdown or HTML, I now have headers, subheaders, all of those things. And so based off of that, I can then chunk the data where the context is relevant, just based off the headers of the document. And that works really well for things like contracts because they're pretty much structured every time. But a drilling report where the first 3 pages are completely different from each other, not as great. So you have to, there's different ways to do this, and there's different times to use different chunking strategies and things like that. But the chunking strategy in and of itself, like RN, I know we had that initially when we first deployed with Kraken. Our chunks were way too big, and he was getting a bunch of bad answers. So we went back, we reevaluated that, we changed the chunking strategy and the chunk size, and now he has much better, much more reliable answers. But again, there's not like a cut and dry, you should always use this under every scenario. It's very scenario dependent. And then here's just another table that I found of kind of the advantages and disadvantages of each of those. Moving on to the embeddings, this is where things get really fun. So embeddings are essentially the graphic representation of words and their relationships to each other. And this is, on a 3D plot, but these are in hundreds of dimensions in real life. And so what you can kind of see here, though, is if they query kitten, kitten is most closely related to cat, which is also kind of related to dog, but not really wolf, and definitely not related to apple or banana. And that's kind of what you're seeing here is all you're doing when you're vectorizing things is giving number values to each of the words and their relationships across a bunch of different dimensions. Same thing over here. You can kind of see, I can see what that is. What is that, the boy one? Yeah. So here's all the vectors related to boy. And the way that we actually figure out, what is matching closest is cosine distance. It's literally the cosine distance between the dots in the vector database. Lastly, that brings us to search. So, I want to go search all of this data now that we've chunked it and embedded it and built a bunch of stuff around it. To get in, before I get into search, I want to talk about MCP real quick because it's kind of pivotal to all of this. And it's not going anywhere. But MCPs are essentially a way for a language model to use an API call. And so this opens up a ton of opportunities for, especially for enterprises where I want to keep my internal data private, but I want to pull in things like public well data or real-time crude prices or my Gmail or my Slack, or do a web search or GitHub or whatever else is out there. If there's a API to it, you can set up an MCP server. So it allows you to ultimately contextualize your data with external data without leaking any of your private data to whatever service you're using. And so what that ultimately looks like is a query comes in, it goes through a router based off of your question. And so if your question can be answered via your documents, it goes and looks in your vector store for that. If it's coming from a database like Postgres or SQL, it can go query for that. If it's coming from a third-party software or SaaS, Slack or Teams or wherever else, it can actually make those API calls there and then bring all of that data back to one place, contextualize it, and give you one succinct answer instead of you having to go 5, 10 different places to get single bits of information to try and put together. So I'm super excited about this stuff. We're slowly starting to roll some of these out into our stack as well. So be on the lookout for that. But again, very similar concept, but this is just a diagram that I made that kind of represents, something that might be more related to what we're doing. But the user query comes in, so you search for something. This is kind of similar to actually the W10 workflows minus the external data. But your query comes in, it searches your RAG, it also searches your production database, and then it does, what is that? A well database MCP. So then it pulls public well data and real-time oil prices from another MCP server, and then it can pull all of that data directly into your answer from one query. And so this is where everything's going. This is, in my opinion, this is where LLMs make the most sense, is sitting as a layer on top of our existing SaaS tools and products and databases, because ultimately, no one likes going 20 different places to find the data that they need. No one likes having all those tabs open, all of that stuff. And so you can literally layer an LLM on top of that as long as there's access via a database or an API call, and have one single pane of glass across your entire organization, across all of your data. But yeah, that's all I had from that. I know Bobby's got some questions.
Yeah. So, I mean, I think the big thing probably for a lot of people here that most people aren't even using AI or RAG yet necessarily internally. What do they need to be thinking about to get the data AI ready? I mean, or what are you seeing? Where is somewhere where people have been really prepared, at least in one side of it, whether it's file structure or the databases or whatever, that actually makes it easier to deploy AI like this?
For sure. No, so that's the thing. Like people, one of the bubbles in that first schematic was metadata. And so metadata is incredibly important in your vector database and in your RAG, because that allows it to contextualize things even more. And so if you have an organized folder structure of like asset, and then within that asset, you've got completions, drilling, reservoir, production, legal, whatever, we will absolutely use that to help contextualize the data and pull that out as metadata for the documents that we have in there. And it makes the searches that much better because it's there. One of the things we're working on internally is building out agents and stuff that will go through and pull out specific types of information. Think of like date, right? Everyone asks, the LLM about different things regarding time. Show me a timeline, show me a history, etc. Well, if we're not pulling dates out and using that metadata, then it's not going to have the best idea of exactly how to structure that, how to order that, all of those things. And so there's a very real future where we have an agent that just goes into every single document. It looks at the file name to see if there's a date there. If there's not, then it goes into the document and tries to find it there. And then if it finds it, it adds it automatically as a piece of metadata in the database, and we move on. And that's how we're able to start doing these things at scale, without having to have a horde of people, constantly manually managing these things. But the big thing, if you have crappy data, or if it's not very structured, not very organized, it's going to be much harder to do than if it's all digital, things like that. But the more information about the data, as is what metadata is, the better, generally speaking. But
yeah, and I think a lot of this was about unstructured data, but even get back into the structured data world. I mean, I think having good models, whether it's you're using Snowflake or Databricks or SQL Server, whatever it is. I mean, I'm pretty sure you guys have been getting questions about text-to-SQL or being able to ask questions in natural language and have it go query the database. Like, what are you seeing there, and what do people need to have in place to make that as efficient as possible?
Yeah, so one, if you move to a cloud version of a software's service, make sure you still have access to the data that they are putting in the cloud, so that if you want to integrate it with tools like this, you can. That has come up. That's fun. But, the big, state the question more.
I mean, I guess if you want to be ready for, or to be able to do, like, say, text-to-SQL or
So on the SQL side, obviously access is the most important piece of that. Some programmatic way that something external can access that data, whether that's an API or a SQL query. But there's two ways to do text to SQL. You can hard code the queries. So for example, with like the WIN regulatory workflow, we're hard coding the calls into the production database because it's the exact same thing every single time. We're looking for the same table, same fields, just different wells. So that one is like just hard coded in there. The other way to do this is to have it be agentic as a tool call where the LLM says, oh, I need data from the production database. I'm going to go call that production database. What it's fed is essentially a description of the database and then descriptions of every single field in that database. And then it's it's writing its own SQL query basically based off of that and then making that call. So that's really cool, but it's also less controllable than just hard coding the query itself. That being said, it's getting better and better. And of course, the better you understand those tables and the more data you have about those tables and those fields in those tables, the better it will work.
Yeah, I mean, I think that's where, and it always sounds good, and usually documentation is out of date as soon as you write it. But like, I think where you can have proper data documentation, data dictionaries, anything like that, where you feed that context in, or say if you're using tools, like I use a lot of like a tool called DBT, where it has relationships between the models and or ERDs or any of these kind of things where it knows the primary and foreign key relationships. Like I think that's where the context that LLMs need for that. Or even just building out like star schemas. It's again, everything is old is new again, but now semantic models are a thing, and it was a thing 20 years ago with SSAS, right, with OLAP cubes and everything else, and now that's the exact same engine that's running behind Power BI in the back end. But that's why I say Microsoft's able to do some of this text-to-SQL or ask a question to a Power BI data set and get the answer back because it actually has the context or the knowledge of those data sets.
Yeah, and so in my experience, it's much better today, and this has probably changed since I've messed with it. But historically speaking, it's much more effective and reliable if it's just calling a single table than if you're trying to get it to call a bunch of tables and do a bunch of joins. The more complicated your SQL query, the less accurate or repetitive it could be. But there's ways to manage that on the back end by creating dedicated tables and things like that.
And John and Bobby, two questions I get asked a lot when we're out talking to folks, and I'll give the example. One client we're talking to has 39 terabytes of data. 29 of the terabytes are duplicates. What are strategies to deal with that? And then the second question we get, particularly in E&P, hey, we're out there making acquisitions every day. We buy a company, we get their data on their file sharing system that looks nothing like how we organize stuff. And we just kind of keep it the same way. Are there strategies, AI cases to deal with either one of those?
What was your first one?
The first one is 39 terabytes and 29 are duplicates.
Yeah, so duplicates are actually, I'm not going to say easy, but the problem is straightforward. So you essentially hash the document, which is creating this giant string, aka a hash of all of the contents of that document. And so you can then just compare hashes to see if you have duplicates or things like that. But it also brings up a good point, like on the contracts side, right? There's multiple versions of contracts, or they get amended and things like that. So like the date and the version, those are pieces of metadata that we want to extract to make sure that we can keep those in order. Because when Ariane asks about a contract, he wants the most updated version of that contract, unless he specifies otherwise. And so that's on us to make sure that we do that. But again, that boils back down to the metadata and the structure of the underlying data set. Your mapping problem, as far as acquiring and then getting it into your structure, there's ways to do that using language models. It's not going to be like an exact science. Here's the same code that'll work on everyone's data sets, but it's ultimately a mapping exercise. And if you say, okay, well, they call their drilling folder, we have a drilling folder, and what they call it operations. And so like that could literally just be a mapping exercise without LLM being involved. But if you wanted to get more granular, you can use LLMs to classify documents and say, tell me what type of document this is. Is it a contract? Is it whatever? And then now you've got a much better idea of exactly what's in there without a human having to go and open every single file. One thing I will say about that is, for whatever reason, our industry is really gung-ho about shoving a bunch of stuff into one PDF that may or may not be related to the other contents that are also within that PDF. And so that's another piece of this that gets kind of tricky, where it's like a lot. And I've noticed this in either like M&A type stuff or just like, oh, that's, from the bankers boxes that we've had sitting around for 25 years. But you don't, it's, it's, it's a tricky problem. But using the language model, like you could literally have a different document type for each page of one PDF, if that makes any sense, right? Like if you just had a third party scan in a bunch of documents and they weren't paying attention, oh, these are all the documents from this asset. But within that one document, you've got drilling reports, you've got post-trial reports, you've got legal, you've got all these things. Well, that document should be split up into multiple documents instead of just one, because contextually, all those things in that document are very different. And so it's a tricky problem.
Yeah, how is the progression? We talked a little bit about this of it learning the context. So you do one project, you learn a bunch of contextual things about specific to oil and gas, specific to energy. How is it possible for it to learn that context just like a young engineer or a young tech would, such that when it goes to the next project, it uses that context and then it adds on and it starts to build on itself such that it eventually get to a point where you can tell it a mission and tell it to go figure it out like you would an actual person. I know we're not there now, but where is that possible, or do you see a path to that?
No, I mean, we're seeing people do this already, right? Like, we've been training Google's computer vision models for decades with CAPTCHA. No one realizes that CAPTCHA is literally just us training, doing computer vision identification for Google, and we have been for decades. But that's why their vision is so good, because they've got a ton of data on that. So as far as this stuff goes, and we're seeing that, like, we use Cursor, we use all these different coding tools, and the more that you use them, even with ChatGPT, the more you use it, the more it understands about you, because it has the history of what you've searched. When I initially started using ChatGPT, I would ask it, what's the formula, or how do I calculate flush volume? And it would give me the volume of a toilet. And now when I ask it that, it knows that I work in energy and I actually mean the volume of a well, without me having to say well in the query. And so, but what that is they're just using the data, the historic data that they've got from your interactions and from all of your stuff to refine the system prompt, basically, whenever you ask your questions. With Collide, we absolutely have intention of building, allowing the profile of each user to be tweaked to what that user is based off what they're searching or based off what we know about them and things like that. But it's a chicken and egg thing. You've got to have enough data in order to then go and train it to do those things, but it still involves training. But what a lot of the tech companies are doing are trying to do this like federated learning type thing where everyone is doing different things at the same time. That goes back to the main model. That gets updated much faster because it's learning across all kinds of variances and different types of data and all of that stuff, and then gets pushed back down once that model gets better. And so that's probably the closest we are to it today, is like, but again, it's still training itself. It's ultimately just training itself, right? Instead of having a human in the loop, they've built all these pipelines and stuff on the back end. Like right now, if you use the copy button in OpenAI, it sends an event to ChatGPT basically telling them that that response was a good response from your actions without you having to go in and click the thumbs up button or whatever. But those are the like really interesting ways that they're able to use user behavior to train and improve these things.
Is that kind of what Colin was saying, like Jasmine is, that's that reinforcement learning side of it?
Yeah, so we just brought on a stud from Microsoft that I'm super excited about, because that's going to be a lot of her focus.
It seems like if you could mimic a young engineer, analyst, whatever, and there's learning from year to year, but it takes the context so we can just go figure it out. Yeah. That'd be a cool thing to be able to do.
Absolutely.
Rather than having to parse it into,
Yeah, and I think if I can answer, and I think to Bobby's point and John's, that's exactly kind of where we are headed, right? With you want to build this knowledge graph, right? And these nodes and these neural networks that over time can self-train through reinforcement learning, through fine-tuned models, through all of these things, so that it can define two particular things. That one is more specificity within oil and gas models, and then also over time taking your persona, right, or the different like operator versus something else, and then just continue to learn through that machine. That's why compute's going to become a really important conversation here, because to do that very effectively, you need more and more heavy compute available to you. Otherwise, you can't do it, right? Because there's just so much data behind this, and that was one of the fundamental reasons why we wanted to go out and get somebody very much trained in traditional ML, AI from like even Microsoft backgrounds and stuff to help us create these sort of models so that we can deploy it for our clients.
Yeah, I think there's just one last thing to drive home here is that I think the traditional data management and just data practices are actually more important maybe than they've ever been. But I think when all this came out, there was the hype cycle and like, oh wait, this is actually going to cover up all of our warts, right? I can just give you a huge S3 bucket of all my data and it'll figure it out, right? And then we realized that's not the case, or an Azure blob, right, Bill, and not an S3 bucket, but but it's actually even more important now. Like, I mean, like that you have your data organized and in order so that you can provide the proper context, to the AI models. Because again, I think people thought it was going to be that silver bullet that, oh, I finally don't. It's fine that I was behind on data because now I can just give it everything I've got and it'll just figure it out for me. But we're definitely not there yet.
But if you were to pay attention to OpenAI and Claude and all the big foundational companies, they want you to think that it's that. Like they do a great job of making it look like magic, or like ChatGPT used to be terrible at doing any kind of math, and then they figured out that it was bad at doing math, so now they let it write Python script and they execute the Python code and then they give that back to the language model. But like if you don't understand that, if you're not paying attention, you're just like, oh, well, it just did math. That's great. It's like, no, they built a function for it to do that explicitly. They built a function for it to go search the web. They built there's all these things happening under the hood that aren't just part of it out of the box. They're explicitly built for certain problems that they're trying to solve. And so that's another piece of this. It's like, yeah, you want this to be like people's expectations are set off of what the foundational models can do. But then if you go to anybody else, those are things that either have to be built or have to be added to the existing stack that aren't just native to it out of the box.
Yeah, I mean, proverbial crap in, crap out is actually getting worse because it can hallucinate on top of the crap.
Yeah, that happens. But that's another benefit of the RAG is constrain it to your data. It might hallucinate, but it'll be grounded in a document and not just made up out of thin air. But yeah, data, the data problem has existed since ML came on the scene, right? And that's why, from the oil and gas perspective, it took us 5 to 10 years to really get into, production worthy, useful ML models, because everyone's like, oh yeah, we'll just throw a machine learning model at it. And then they got down the path and like, oh, half of our data sucks, or none of it's normalized, or whatever it may be. And so they had to take the time and spend the money to invest in getting the data where it is structured, it's cleaned, it's organized, and then the models work and they work great. It's the same thing with natural or language models, right? So, and that's honestly in one of the talks that I do. I tell everyone, machine learning came around because we generated so much machine type data, numeric data, that we as humans couldn't process all of it. We needed a machine to help with that. Large language models are the exact same thing, but for text.
When on the topic of context, do you find that materializing a context like dictionary, some type of table, is kind of like your go-to, or kind of like how do you define it? Like, I think the topic of trying to rely on reinforcement learning and all that is like, to me, it sounds like I get it. Hopefully it works out, but it's like at some point you still have to define like what starting to play for me. Like, what is that actually?
Yeah, no, I mean, the nice thing with RAG is that we can just give it a dictionary as a data set, and now it has that into it. And then we're working on fine-tuning models that have that built into it directly so that it can recognize all of those different fun jargon terms that we have in our industry and things like that.
So dictionary being one that you define, or like you're actually?
No, it's a dictionary that we built from a bunch of different glossaries across the industry. But yeah, that's another thing with RAG is like You don't have to train these things. You just give it the context. And it doesn't have to be RAG. It can be your chat GPT instance. I tell people that all the time, right? GPTs are predictive models. If you don't include the context that you're trying to get the answer to, it's not going to do a very good job generating an answer without the context, because that's how it generates the answer, is based off of what you asked it. And so, like, if you're doing API calls, if you're doing any kind of coding, give it the documentation, link to the GitHub. Like, there's so many ways to get context into these things now that make the answers infinitely better, infinitely faster, and way more useful. You're spending way less time iterating and telling it to fix it. Also, that's a terrible follow-up prompt. If it generates code that doesn't work, fix it does not help it very much. You need to tell it what is wrong or what it needs to fix.
My favorite story when we're out there talking, because one of the pitches of AI is you talk to all the legacy software, you talk to all the disparate data sources, and that's truly where the magic happens. And anytime they ask me, oh, can you talk to this? I always say yes. John rolls his eyes in the meeting, and I watch what color red he turns to know how hard it's going to be to actually talk to that software. So
we have a great relationship. No, I love Chuck.